Good afternoon, good evening, or even good morning from wherever you're joining us from the world. I am Jarka Glassey. I'm the Vice President Executive of the European Federation of Chemical Engineering, and currently I'm in my second term as a Vice President. I graduated as a biochemical engineer from the Slovak Technical University in Bratislava in Slovakia, and until recently I worked as a professor at Newcastle University using various modeling approaches to bioprocess development and optimization. So although I can't really consider myself an early career, I am really excited about being involved in the introduction of this webinar on navigating diverse industry and research paths, an interactive roundtable with early career chemical engineers, and I'm really looking forward to participating in this webinar. But first, let me say a few words about the Spotlight Talk series. This is now our 6th year of the Spotlight Talk initiative, which started in 2020 to help us keep together the community during the COVID pandemic. The success of the previous years convinced us to transform the spotlights into a regular feature of the EFCE program. And we now have one spotlight series in odd years, like 2025, and 2 in even years. So this spring, 11 of our working parties and sections delivered over the last 2 weeks webinars with talks on specific topics by leading industrial and academic experts. And I believe, our early career colleagues have the privilege to be closing this series of webinars for us. But these series enable attendees to sample matters in new areas, encouraging them to cross-fertilize their interests. And you can see the whole program on EFCE website. And if you're really interested in some of those that you may have missed, there will be recordings available too. EFCE promotes scientific collaboration and supports the work of chemical engineers in 30 European countries, representing more than 100,000 chemical engineers in Europe. EFCE's working parties and sections cover all major specific aspects of chemical engineering and are in fact at the core of our organization, forming the scientific engine that drives many of EFCE's activities. They provide an important forum for technical knowledge exchange and networking among chemical engineers in Europe. And I would really like to encourage you, if you're not already involved with our working parties or sections, to consider joining. The section membership is open to colleagues working in the area and it is individual, although for working party membership, delegates are either nominated by the National Member Society or elected by the working party. If you are interested in joining, do reach out to us through our website or your national member society. Before concluding, I would like to thank all the people who worked hard inside the working parties, sections, and in EFCE in general for this initiative to happen and to be successful. And as usual, in particular, absolutely great thanks to our EFCE's Martin Pu in Toulouse, who did most of the conceptual setting up and practical activities. I'm also pleased to inform you that the EFCE board has decided to award Martine the prestigious Dieter Behrens Medal for her contribution to chemical engineering, and this medal will be delivered to her at the ECAP conference in Lisbon in September. So again, Martine, thank you so much and congratulations on this well-deserved award. Okay, so thank you for your attention, and I wish all the speakers and the attendees a fruitful and successful webinar. And I will now hand the word back to Sofia Garcia Fracaro, our chair of the section on early career chemical engineers, and she will start the proceedings proper. So good luck, everybody.
Thank you, Jarka. Hi, everyone. Give me 1 second to share the screen. You should be seeing it now, right? Yes, thank you for the feedback. Welcome everyone to the Spotlight Talk 2025 of Early Career section. My name is Sofia Garcia Fracaro. As Jarka said, I'm the chair. I'm chemical engineer, bachelor chemical engineering. My master was also in chemical engineering. And I did also a PhD in chemical engineering, but more allocated to how we can use virtual reality and augmented reality to train chemical operators. So I went a little bit more into education. I'm happy to host this session for today with 4 different early careers and different career paths. And give me 1 second to first introduce what is early career in case you are new here. So you get a little bit of understanding of where is our section. So the goal is to bridge the gap between being a student, early career, and going into academia or industry as a worker. We meet every month all the general members, and we try to exchange experiences into if we are working in academia, how is it going? Where are PhDs open? What is our experience? What are the research that we are doing? And we also we try to organize when we go to a conference, meet all together on that conference. There is a lot of things going on right now. We have also a WhatsApp group, and my co-chair, Sylvie, will share in the chat in a second the link to join our WhatsApp group as well, because we have a job section where many of the members post opportunities for early careers in academia or in industry, scholarships, and we try to keep that network alive. We define early careers not based on age, because things could happen in the middle. Your career path could be really diverse. So we try to define it as 8 years after the master or 4 years after your PhD, and holding a bachelor or working towards getting the bachelor. We are located all in Europe. We have a board of 10 members and approximately 60 general members. We are trying to cover as many countries as possible. We have new members coming in every month call. We have new members that are introduced, and we are really happy of being an active section which is growing, which only enriches us and make us stronger, I think. What we do, we have different task forces. That's how we organize our work. Basically, we volunteer to do a specific task, and we do the task. We have a social media team that takes care of our LinkedIn, our Instagram account. That's a hint to follow us on LinkedIn and Instagram. We have shared already the link in the chat. And our social media team as well takes care of the EFCE LinkedIn account. Then we have a task force that does the Spotlight Talks. So the one that we are here is organized by this task force. The first one that we did was in November 2020. No, sorry. The second one that we did was in November 2024 and was focused on essential skills in industry and academia. And you can watch the recording here if you scan this QR code. It's in YouTube, it's free, and it was a great session. So I really encourage you to watch it. The third one is the Early Career Program for the ECCE conference that is going to take place in September in Portugal. We are going to have different sessions, talks, interactive workshops, a pub quiz on the first night, and a photo booth to take really nice pictures when we are nicely dressed in the conference, so you can use it for LinkedIn or your CV. We are organizing coffee talks to allow the different working parties of EFCE to introduce themselves, so we early careers understand a little bit better what they do and how we can participate in their activities. For 5, we have travel grants and awards. If you have applied for an abstract submission in the ECCE conference, You can apply it until 31st of May, so in 10 days for a travel grant to go to Portugal with this travel grant. And we also have plenary lectures, early career plenary lectures, and we are going to have one plenary lecture in Portugal. We will share the details of which one is this one very soon. And if you are in Portugal, you have to come. It's mandatory by me to become and support your early career peer. And finally, we have the beginner's guide. This is the brand new information. If you scan this QR code, you will find a map of several, so it's a map of Europe, and you will see different associations and early career subsections of chemical engineering societies, and you can see what they are doing, what are the activities, and this was organized by our beginner's guide task force. So I encourage you also to go and explore it. And we are planning to organize a mentoring program in the future, but yes, this is what we have done so far, and more will come soon. Now, I mentioned that the Early Career Spotlight Talk is one specific task force. Theodoros is the lead of this task force, and we are 5 members that organize this together. Basically, we found the speakers, we organized, we set up everything, so today we can have a successful session. And yeah, I have the names here, but a big thank you to everyone, Theodoros, Alper, Xenia, Morgan, and Andrea, for the great work. I think the session is going to be great and really insightful for all early careers, and we couldn't have done it without all our work, so congratulations to us. Good. Now, you are here in the session of, I cannot read the title because I have the, thank you, Zoom. The session that's called Navigating Diverse Industry and Research Path, an interactive roundtable with early career chemical engineers. So what's going to happen is we are going to have a presentation by each of these early careers. So we have Sofia Palagonia. She will have a presentation about, the title is From Theoretical Simulations to Practical Challenges, a Journey of a Chemical Engineer. Then we have Stavros-Alexandros. He will present on the interface between industry and academia, a chemical engineering pathway. Alexandra Antunes will present From a Lab to Leadership, a chemical engineer journey through research, consulting, and entrepreneurship. And Eleonora Ricci, will present about walking the line between goals and exploration. You can see here, we have 4 early careers, which are going to show us how their career was really different between each other and how they switch from industry to academia or the other way around. And I think it's going to be very insightful. Before we move into the first presentation, I want to ask you 1 second. Okay. To please go into Menti and tell us what is your education level, because it will be interesting to know if you are a high school student that join us to know what a chemical engineer is doing, or you're a bachelor and you're trying to see where to go next, or not, you're a master, PhD, post-PhD. So you have to go to menti.com and type 4388 5835. Okay. We're really surprised if there are high school students. But if you're watching the recording after, hi. You will learn a lot about what a chemical engineer can do. Ah, there is a high school student. Hi. Good. Okay, so we have 17 people that have replied. I don't know exactly how many speakers, presenters we have today, but good. Then I can switch to the next question. Okay, more people is answering, so.
Yeah, we have nearly 50, I think, or 40 odd.
Oh, nearly 50, okay.
Yeah.
I'll give you one more minute to get to menti.com. And it's weird that I cannot type in the chat, but it's menti.com. Here you see it. And then 43885835. Okay, and then I have a second question, so don't close it. Is where do you work? This question was more to know if you are a student of one of those categories, you're a researcher, already a professor, or you're working in industry. Okay. I think this gives us a good overview of who we have today. Thank you, everyone, for your answers. I'm really happy to see this. Okay, good. And with that, I'll jump back to here. We'll start with the first presentation. And after all the presentations, we will have a roundtable with questions where all the speakers will answer questions. And then if you have any questions, you can write them in the chat where it says Q&A, and we will go through them at the end. If we don't have time, we will answer them afterwards. You have to type the questions. You're not allowed to speak. You don't have the functionality, but write the questions and we will answer them. And with that, I'll give the floor to Maria Sofia Palagonia. I'm going to do just a quick introduction because she will introduce all her career, but she's a chemical engineer specializing in industrial processes, optimization, and circular economy. She holds a PhD in production engineering from the University of Bremen, and she currently serving as an excellence assessment manager at Covestro. So, Maria Sofia, the floor is yours. I'm stopping sharing.
I'll share my screen. You should be able to see it. Do you?
Not yet.
Not yet.
All right.
You may have a double screen.
Yeah, I do. That shouldn't be a problem, right?
No, but maybe did you click on share at the end?
Yes, I did. 1 second again. I try.
That's getting better.
Okay, good.
Yes.
Right. All right. Good afternoon, everybody. I'm very happy to be here and giving this presentation about my career. And the title of my presentation is From Theoretical Simulations to Practical Challenges, a chemical engineer's journey. So first of all, who am I? My name is Maria Sofia Palagonia. I was born and grown up in the beautiful city of Palermo in Italy. I'm 34 years old. And my career actually started in 2009 when I had to decide which university path to follow. And it wasn't an easy decision, actually. I was good at many subjects during high school, and I was passionate about many things. I was probably what we would call today a multipotential personality. So to give you an idea, in high school, I won both the philosophy and the chemistry Olympics at my school. I played guitar in a band, and this actually didn't change. This picture in the slide is a couple of years ago old. And I liked literature and art, as well as chemistry and math. But in the end, I decided to trust the logical part of my brain and go for a scientific path. And that choice gave me the chance to apply my passion for chemistry on a more technical level. During my master's, so I decided to enroll indeed at the University of Palermo, and where I run my bachelor and master program in chemical engineer, and started in 2009, and I graduated in 2015. And during my master's, I had the opportunity to work for 4 months at the Corrosion and Protection Center of the University of Manchester, funded by the Erasmus Plus program. And there I ran the experiments that I later used to write my master's thesis, which was a study on the growth of oxide layers of magnesium metal through electrochemical methods. What did I take from this experience? Well, besides my thesis, I also published my first scientific paper on the anti-corrosive properties of magnesium oxide layers. Just to give you a spoiler, they don't have any anti-corrosive properties, so you don't need to read the paper. But even more importantly, I had the chance to live in a new country, get out of my comfort zone, meeting inspiring people, improve my English, and really dive into the scientific method. I would have probably never applied for a PhD without this experience. And after graduating with full marks, I decided that I wasn't really ready to for the corporate world or to join a company and start to work, but I wanted to keep doing research and experience new things and moving abroad again. And that's why I decided to join the program, the PhD group of process engineering with focus in electrochemical techniques at the University of Bremen in 2016 in Germany. During my 3 years PhD, I developed an electrochemical reactor to extract lithium from concentrated brines. And the motivation of the work was the increase of lithium demand due to the increasing demands of lithium-based technology, such as rechargeable batteries for energy storage or automotive industry. There is a strong need of sustainable and cheaper technology for the lithium extraction, and that's why I developed this reactor that works a little bit like a battery. So there is two electrodes. One of the two is a lithium capturing material that can capture lithium ions from the brine by means of the application of an electrical current. And I studied the parameters that influence the behavior of the reactor, such as the pressure or the current density, the amount of active material on the electrode, and so on. And by tuning the current density and the flow rate of the solution through my electrodes, because the reactor was a flowing through electrodes reactor, I could reach the 95% of capture yield, of lithium capture yield. Moreover, during my PhD, I decided to model also my reactor. So I wrote a mathematical model to describe what was happening in the reactor. And this was actually one of the most challenging tasks of my career, I think. I had to use all my engineering background, developing a keep attention to detail, and also to use a big doses of patience. But in the end, this was challenging as well as rewarding. Indeed, I will never forget the day in which the model finally predicted very well the reactor behavior with the parameters. In 2019, I graduated at the University of Bremen, and I also won a prize for this thesis as one of the best PhD theses at the University of Bremen in that year. And the company where I work now, Covestro, dedicated also a nice internal, a nice article in the internal website. So after my PhD, I decided that my academic journey has come to an end, and I decided to do the transition to industry. And I was hired by Covestro, which is one of the leaders in the world of polymer manufacturing. It's based in Leverkusen, Germany. And we have several plants, more than 50 plants in all the world. And the most produced in amount products are polyurethanes, both soft polyurethanes and hard polyurethanes used for various industry, and polycarbonate used in the automotive industry. In Covestro, I was hired as simulation expert, and that gave me the chance to apply modeling and simulation skills that I acquired during my PhD for big plants, so for real chemical processes, both for already existent plants. So I worked with simulation to supporting plants when they have a problem or when they want to optimize something. But also I was developing mass and energy balance for new kind of processes, mostly recycling processes, in the frame of circular economy projects. For example, I had the chance to work in the Circular Foam project, which was a European-funded project with many research centers and universities involved. The focus of the project was the recycle of rigid polyurethane foams, such as fridge. The hard polyurethane are mostly isolating materials, for example, used in the building industry and also fridges. And I also participated to a project called EvoCycle for the recycling of soft polyurethane foams, which are mattresses. And of course, the kind of process simulations that I was developing was quite different from my previous one. So before I had only a reactor, and I modeled in detail that reactor. Here instead, as you can see in the slide, there are many units connected to each other. And it was also very exciting because I got to model what was happening in the lab and in the mini plant with various units. And I stayed in this position for 5 happy years. I also learned new skills such as data analysis, and I also participated on a couple of digitalization projects. But last year, I started to wonder what would happen next, so which could be my next step. And the question that I had to reply was if I wanted to become an expert or so stay in the position and basically becoming a simulation expert for Covestro, or doing something else. And actually, my multipotential brain knocked at the door again and telling me that I wasn't really fully satisfied yet. So I've been doing math, chemical engineering, process simulation for the past 8 years. And it was time for doing something new. So I decided to join a plant assessment program that was running in Covestro, which is basically one or more teams. It consists of one or more teams going in different plants worldwide and in Germany, and analyzing how they are working, how good are the workflows, and possibly writing some suggestions and optimization tasks for the plant. And actually, when my manager proposed me this kind of position, I was quite skeptical. Because basically I spent 8 years mostly working with computers, data, models. I consider myself a little bit of a nerd. I hadn't really practiced my soft skills in a long time. And most of all, I doubted that my German was good enough to do this job properly. Basically, all the plants that I'm analyzing with my teams are in German. But I heard that familiar voice inside me saying to take the chance and challenge myself, and that's what I did. So now I am in this position since more or less 1 year, and I finally got to see how a real chemical plant works, and I could translate in theory in practice all the theory that I learned. And in our analysis, we use tools such as data analysis, of course, but also a lot of other tools that has to do with people. So workshops with the people in the plant, interview, employee shadowing. And we analyze how the work in the plant is done, all the workflows or many possible workflows, and then we find solution for optimizing it together with different parties, such as the plant heads, the management, and the work council that is always there to defend the rights of the employees. And actually, what I realized is that beyond the models and beyond the theory, a chemical plant couldn't work without the people. And it's been amazing to reconnect with people. And I realized that this is exactly what I was missing in my previous role, talking to people, discussing problems, finding solutions together. And by doing that, using my logical thinking mixed with a good dose of empathy, I realized that all my previous doubts were disappeared. So my takeaway message for you today is that the only real obstacle to your growth and your goals is yourself. And I will say to not be afraid to take new opportunities and don't underestimate your abilities. And also don't be too hard on yourself. Even if you're not the best today in something, you can become better tomorrow. And even if you don't become the best or you don't become even better, you will learn something about yourself. And in a society that constantly pushes us to be perfect, to fit into a mold, to follow well-defined paths, I believe that being yourself is the true key to success, especially in the workplace. And the diversity, courage, and new perspective are the only way to push the challenges that industry, especially chemical industry nowadays, is called to make. And sometimes as women, we need to challenge, we have more challenge sometimes with respect to our male colleagues because it's just a few decades that women started to study STEM subject and applied for position who has been men typical for many years. And although we are completely entitled to cover those positions, still 75% of women in leadership positions have experienced imposter syndrome at some point in their careers, according by a study of the American Psychological Association. So 75% of women often underestimate their capabilities, even if when their performance matches or exceeds that of their male colleagues. So it's a pattern that is difficult to break because for centuries women has been relegated to other roles. But now we have the chance to be here and raise our voice. We often feel that we still miss something. So we have the urge to feel perfect before allowing ourselves to speak up, proposing the perfect idea, or having the perfect accent. But that must change. So today, more than ever, the engineer world feel the urge to embrace more empathy in the workplace towards our planet and the people who live on it. And we as women, we need to step in and be the protagonist of this change as well. So let's stand up and speak, even if it's not our mother tongue, even if it's in German, even if we make mistakes. Thank you for your attention.
Thank you, Maria Sofia. That was amazing. Thank you so much. We'll keep the questions at the end. And now we will switch to Stavros. Sorry. Thank you, Maria Sofia.
Thank you. Thank you, Sofia. Let me share my screen.
I need to introduce you while you share the screen. Dr. Stavros-Alexandros Theofanidis is a chemical engineer who studied in Greece, chemical engineering, and he did his PhD in the University of Ghent in Belgium. And he is currently the co-founder and chief technology officer of AristEng. The floor is yours.
Thank you, Sofia. I guess that everybody can see my screen now.
Yes.
Excellent. Let me put the laser. So I'm very happy to be here today, and I would like to welcome all the participants. Yeah, my name is Stavros-Alexandros. I'm the CTO and co-founder of AristEng Sarl. AristEng is an engineering firm. It's headquartered in Luxembourg, and we also have the registered offices in 2 locations in Greece. The talk today will be related to a different chemical engineering career pathway, which does not solely belongs to industry or academia, but it is on the interface between these 2 options. So as young researchers, as young chemical engineers, there are a lot of things now that you have in your mind about your next step. Should you apply for new jobs? Should you apply for PhD positions? What about work-life balance? What about grants, funding, etc.? And I have to admit that this is absolutely normal. Everybody being at your position at this stage, we will have the same thoughts. But now I will talk about myself. I was graduating as a chemical engineer on April 2013 from Aristotle University of Thessaloniki, Chemical Engineering Department. And at that point, I had no idea what should be my next step. So I started applying for different jobs. And I have to admit that I failed to most of the applications that I did at that point. Then I started thinking, okay, maybe let's start applying for PhD positions. I need to have an expertise in a specific field and then enter the job market. And this is how I did my next step. I went to Ghent for a PhD on 2014, and I was graduated in 2017, holding a PhD in chemical engineering in catalysis field. Then I stayed a bit longer in Ghent to do some extra research as a postdoc to complete actually my previous work, where I realized that mobility is important in our field. So I returned back to Aristotle University of Thessaloniki, but this time not as a student, but as a researcher doing a postdoc. And during my research in Aristotle University of Thessaloniki, I also had some visiting researcher scholarships going to France, to ESRF, European Synchrotron Radiation Facility, to perform research related to the subject of my postdoc. And then on 2021, May 2021, we established AristEng with a good friend and colleague. And since then, actually, that was the switch point, let's say, going from an academic environment to a corporate environment. Yeah, so all the thoughts that you have at the moment in your mind could be summarized about the uncertainty for the future, could be summarized in one question: which career pathway to follow? To help answer this question, we could do a semi-quantitative analysis between comparing two major options: academia versus industry. And in this slide, we use 6 key indicators, which is the freedom to explore new ideas, ongoing learning, competition, job stability, salary, and work-life balance. So starting with the freedom to explore new ideas, you see academia scores higher than industry. Being in academic environment, you have the freedom to, you have more freedom to explore your own ideas, and maybe those ideas could result in some good results that could be published in a scientific paper. And you know that in academia, publications is a very important metric, a key metric. While being in industry, the freedom to satisfy your own curiosity is more limited. Your tasks are more well-defined, well-structured, and this is because industry targets not on scientific papers, but to increase the sales revenues. Regarding the ongoing learning during your career or knowledge gain, academia, in this slide, shows that academia scores higher than industry. This can be debatable. The reason behind the higher score of academia is the fact that being in an academic environment, you might be involved in several projects where you will have a more holistic view of different processes, and this results in higher knowledge gain. But of course, industry gives you more specialized knowledge on specific fields, which is also very useful. Competition is the next indicator. Without any doubt, being in an academic environment is much more competitive than being in industry, and the competition is higher in terms of applying for grants, for publications, even getting a permanent position. One important indicator for many young scientists is job stability, and this is an indicator that industry scores higher, and since the financial situation is more stable in industries compared to academia, which is a grant-seeking environment. And this is, of course, associated to the next indicator, which is the salary. The position, most of the positions in industry are more competitive in terms of salaries compared to academia. And the last indicator, the last metric, is the work-life balance. Well, this is a difficult one to evaluate. I believe there are two main contributors to this metric, and one is first of all the flexibility in working hours, and the second one is how many hours you spend doing your job compared to your free time. Being in an academic environment, apart from your main job, you normally have other assignments. You might have teaching assignments, you might have administrative tasks to do, compared to an industrial environment where your tasks are more, let's say, well defined, well structured. Therefore, you see that the work-life balance, the ratio, the score is higher in industry compared to academia. But now there is a question: is those two options, academia or industry, are the only possible career pathways that you have to follow? And the answer, And the answer is no. There are different career pathways that you can follow, and actually there are companies that are working on the interface between academia and industry. They are linking actually academia and industry. It's still a corporate environment, so it's different from being in academia or in big industries. What is a subject? They try to combine fundamental knowledge that already acquired in academia with real industrial challenges. And to do that, you try to link those two environments exploiting data, research data, experimental data generated in academic environment, and using some process design or synthesis principles to generate mass energy balances, which will be the basis to apply some assessment tools like techno-economics or environmental assessment or social assessment. And let's see how this different environment, still a corporate environment, but different from big industries and academia, score in terms of indicators that we saw before. And as you can imagine, since we are discussing that we are on the interface between those two environments, the scores should be in between. So indeed, you have higher freedom to explore your own ideas compared to industry. You, again, in being in such corporate environment, you have high knowledge gain because you are involved in several projects, you are in touch with several real industrial problems, and you have to develop several processes. So you have a wider spectrum of processes that you are involved. The competition is lower compared to academia, while the job stability is higher. And why is that? Because those corporate environments are not 100% dependent on grants, but there are always private contracts in place which differentiates the situation compared to academia. And this is, of course, linked to salaries, where the salaries are more competitive compared to academia. And the last metric, the work-life balance, maybe I'm a bit biased here, but I think that the work-life balance is also better than being in an academic environment where you have more assignments and more tasks to perform. So the purpose of those companies is to bring the gap between the two main pillars, which is academia and industry, and it's like a connection to work together. And this is what AristEng Sarl does. It is on the interface between those two main pillars, industry and academia. And our business model currently combines public funding, so grant seeking, and private contracts with several companies, which could be startups, could be small, medium enterprises, or even big industries. And I have to say that this was not like that in the beginning when we started AristEng. This business model evolved through the years, because in the beginning, our business model was like 90% dependent on public funding, on grants, while today we have a more well-balanced business model between public funding and private contracts. As you see in this figure here, in this representative figure, public funding is around 50%, a bit higher than 50%, while if you sum the rest, which corresponds to the private contracts, is around 45%, summing startups, SMEs, and industries. And this really highlights being, in the interface between those two pillars, academia and industry. And what we do, what are the services that we offer? As I said, core expertise is process design to generate mass energy balances for different processes, and then assess the process using techno-economics, using environmental impact assessment tools, or try to optimize the process in order to decrease the energy cost. And this is from my side. I would like to thank you for your attention. You can find AristEng. You can follow AristEng in LinkedIn, Instagram, Facebook, social media. We are active, and or you can visit our website to learn more about AristEng. Thank you.
And I will definitely look more into it. It sounds very interesting. Thank you. And now we move to Alexandra, who is our third speaker. While you share your screen, I'll do the introduction. Dr. Alexandra Antunes is a chemical and biotechnology engineer. She's also trained in entrepreneurship and biotech at MIT and Porto Business School, and currently is a business analyst at Accenture and a co-founder of AristEng.
Can you hear me properly? Thank you.
But we don't see your screen.
Let me share my screen. Okay.
Perfect. And now we
just started. Okay, can you see it properly?
Yes, perfect.
So welcome everyone to this new EFCE Spotlight talk. So today we're gonna talk about how, as a chemical engineer, I went from lab to leadership, and we're gonna see what I did during my journey as a chemical engineer in research, consulting, and entrepreneurship. So, okay, is it working? So on today's program, we're going to talk about how you can bridge science and strategy and apply your engineering thinking to business and innovation, how you can embrace risk and reinvention through different fields, and how you can leverage your chemical engineering skills to build a sustainable impact through collaboration and resilience. So first, I'm going to introduce myself. So I'm Alexandra. I was born in France. I moved to Portugal in 2018. That's when I started studying chemical engineering. I specialized in biotechnology. I then did an exchange in Hong Kong where I studied more business classes and entrepreneurship. Then I did my master thesis in research and development in a laboratory of nanomedicine in the field of biomaterials. And as a side project, I worked on a coral restoration project. Then I came back to Portugal in 2024. I started working in IT consulting, and that's where I started founding AristEng. And as my latest professional experience, I was invited to the Universal Exposition 2025 in Osaka. It was last month to represent this coral project that I worked on in Saudi Arabia. So first, we're going to see how, as a chemical engineer, you can bridge science and strategy and apply your engineering thinking to business and innovation. So what is engineering thinking? So engineering thinking, it's about thinking in systems. So as a chemical engineer, you're very valued because you're able to see the whole picture and hidden patterns. That's something that you can apply in several fields. For example, in consulting, I have to see the CRM that we're developing every day as a whole and to be able to instruct proper features. Engineering thinking teaches you how to be critical and challenge always what's assumed. That's something you can apply, for example, in research, not assuming that every solution is already optimal and perfect, and trying to improve all the time and find problems. That's where you're going to use your third skill that engineering teaches you. So you're taught to how to break problems and simplify the complex piece by piece. And it's also useful in entrepreneurship. For example, in my case, in AristEng, we're developing a coating for the jewelry industry to make every piece of jewelry anti-tarnishing, hypoallergenic, and more resistant. And we need to approach the product development phase in modules to improve adhesion, toxicity, durability, etc. Engineering teaches you how to be solution-oriented, so you're used to analyzing and also providing solutions and building forward, so you're told how to deliver and to think also outside the box. So chemical engineering allows you to contact with a lot of different technology and fields, and you're expected to invent by combining the unexpected. For example, on this coral project I worked on, they combined 3D printing with biotechnology to 3D print new corals and solve the reef bleaching issue. You're also taught to analyze and optimize, so you're able to use data and use it to drive decisions and improve. That's also applicable in very different fields. And you're also taught to anticipate, and I think that's a skill that you can apply to yourself as a professional in every field. Because you're taught to anticipate, you should always try to get exposure and new knowledge and network to improve yourself as a professional and as a person. So that's why chemical engineers are a great fit for many roles and industries and places also. So now, I will show you how, if you're thinking about changing field or if you're in an in-between, you don't know what to choose, how you can embrace risk and reinvent yourself, because it creates opportunities. So that's how, in my opinion, I embraced risk and what it brought me. So for moving to Portugal from France at 17, I learned new languages. Now, actually, I'm currently in an international project. I'm leading a very multicultural team. I'm very at ease with both cultures. Then in my exchange in Asia, it taught me how to get out of my comfort zone, and it brought me new knowledge and tools to build my business, as I studied business and entrepreneurship, and it broadened my horizons and network. Then I got the chance to experience a research and development in two fields. So biomaterials for nanomedicine and climate tech for coal restoration. And in terms of opportunities, I got to contact with different technologies, gain some research and development experience that I can now apply in my entrepreneurship journey. And that also brought me to Japan, where I could represent the project at Universal Exposition, which was an amazing experience, by the way, and even extend my network. Then I switched to IT consulting because I wanted to gain some experience in informatics and also in the corporate world, where I get to experience the rules of the corporate world. I'm able to lead a team and learn team leading. There are a lot of learning opportunities, and that's a great place to learn transversal knowledge and also apply what you learn in engineering. And more recently, by founding my own venture, I can apply all this knowledge that I got from all the experiences. And I got the chance to be selected for the Silicon Valley Fellowship, so that's going to be a new experience and probably more opportunities, I hope. So now we're going to see how, as a chemical engineer, you have the tools and the knowledge to build a sustainable impact. So why you should bet on sustainability as a chemical engineer? It's because today, if you solve a problem, you need to think about the consequences tomorrow, and industry, academia, and all the fields are betting on sustainability. So in research and development, you will be able to build, to participate in sustainable projects through cross collaborations in a bunch of fields. So if you're not sure and you don't want to follow the traditional path, you can, for example, bet on health tech or participate in the climate tech projects. So you have a lot of opportunities if you're going into academia. In consulting, it's a bit less obvious, but as a software developer analyst, I'm an advocate of green software practices. So now industry and consulting are trying to integrate sustainability even in informatics system design. So for example, by assessing the carbon footprints of systems and propose improvements. That's a way how you can link your chemical engineering knowledge to IT consulting. And through entrepreneurship, so now with all the knowledge I acquired in those fields, I am able to work on developing eco-conscious products and combine my chemical engineering knowledge and consumer needs to reduce waste and build a venture grounded in values and not just focus on viability. So as key takeaways, I would say that as a chemical engineer, you're a natural problem solver and it's very valued in the industry because you're able to see the big pictures, find the problems and deliver a solution. I would recommend to bet on sustainability early on because companies today seek engineers who can align products with environment, social and governance goals for future regulations. You should be open to reinvention because today's world is very fast-paced and showing flexibility and multidisciplinarity is also at your advantage. You should lead with purpose. So if you're value-driven, you will inspire trust and attract people and opportunities. By building global experiences also, you can adapt easily to today's projects which are the norm. Normally, they're global and more international. And you should also grow your network because at the end of the day, decisions are made by people and build real relationship with people. So your managers, go to conferences, events, like you're not only your CV, even as a professional. Thank you very much for your attention. And if you have any question, don't hesitate in connecting. You have the QR code to my LinkedIn if you're interested, so feel free to reach out.
Thank you so much, Alexandra.
You're welcome.
Also extremely interesting. Please, if you have any questions, as Alexandra, you can reach out to her directly or write your question in the chat. We will take them at the end. And now we move to our next speaker and last, Eleonora. While you share your screen, I will do a little introduction. Dr. Eleonora Ricci is a chemical engineer. She holds a PhD from the University of Bologna and has followed by a postdoctoral work at the University of Bologna, and she is currently a lecturer in chemical engineering at the University of Edinburgh. The floor is yours.
Okay, thank you so much for the introduction. Can you see my screen properly and hear me well?
Yes, it looks great.
Amazing. Well, First of all, thanks to the early career section of the EFCE for the invitation. It's a pleasure to be today and be able to share a little bit about my career journey so far with all of you. So I will start from the end, which is where I am now. I'm currently a lecturer in chemical engineering at the University of Edinburgh. And lecturer is the UK equivalent of assistant professor, basically in other countries, which means that I teach and I do research. Currently, I'm teaching a class about unit operations, about batch unit operations, which here in Scotland with all the distilleries are quite important and relevant. And regarding research, I work on materials design using computational methods. In particular, I study polymer and polymer nanocomposite materials that are used for energy and environmental processes, such as, for example, gas separation membranes, which are used for carbon capture, or ion exchange membranes that are used in fuel cell applications, or barrier materials that are deployed in the hydrogen infrastructure. And how I study the properties and the viability of using materials in these applications, I combine various modeling techniques, such as molecular simulations, but also data-driven techniques and physics-based models, such as thermodynamic equations of state. Also working on the development of combined modeling strategies. So how did I get here? So let's go back to the beginning. And I come from a town called Modena in the north of Italy, which is famous for good food and sports car and lovely medieval architecture. I did most of my education in the nearby town of Bologna, which is also famous for good food, sports car, and beautiful medieval architecture. And specifically, I obtained a bachelor's degree and a master's degree in chemical engineering at the University of Bologna. Now, the University of Bologna is very special because it's been in operation since 1088, making it the oldest in the Western world. And Bologna as a city is very much shaped by its university culture and student life. So it's a great place to be as a student. And I'm really grateful that I had the opportunity to get my education there. What happened is that towards the end of my degree, I attended in the last year, in the 5th year, an elective class about molecular modeling. And I really enjoyed it. So I decided to base my master's thesis project on this subject. And from there, I had the opportunity to apply for a PhD position at the same university that allowed me to continue working on modeling of materials. During my PhD, I spent 10 months as a visiting student at the National Technical University of Athens in Greece, where I had a chance to train even more on molecular simulations. And it was the first time for me living abroad, and it was a very rich experience in terms of both professional and personal growth that taught me many lessons that I brought back with me when I came back to Italy to finish my PhD. I graduated in March 2020, beginning of the pandemic. So we inaugurated, let's say, the remote graduations procedures. So it was quite an hectic time, but for 18 more months, I stayed on at the University of Bologna as a postdoctoral researcher and also as an adjunct professor, meaning I was teaching one class, which was incidentally the same molecular modeling class that had inspired me to pursue research in the first place, which was a very rewarding experience. After this, I won a Marie Curie postdoctoral fellowship that allowed me to spend the next 2 years working at the National Center for Scientific Research Democritus in Athens. There I was based at the Institute of Informatics, and I had the opportunity to learn about machine learning and train on data-driven methods. And I worked on a project that aimed at combining machine learning and molecular modeling techniques so that we can improve the reliability and efficiency of these computational methods. After this experience, you know what's next. I got a job as a lecturer in chemical engineering at the University of Edinburgh, which I am currently. Now, that's not the end of the moving around, because last year I also had the opportunity to spend a few months working in a research company called Sintef in Oslo, again in an informatics department, which also gave me the opportunity to continue training on these skills that I can apply in my research work. And currently, I'm back to the UK. So when you put it like that, all next to each other on a line, it looks pretty straightforward, also like a natural progression. But the truth is that there were always crossroads at any step, and I would like to share a few of those. So the first one was in a similar spirit to what Maria said right at the beginning, like it wasn't an obvious choice what I wanted to study at university. I was coming from a very different background in high school. I didn't study STEM subjects. I was studying foreign literature, but I had developed an interest for STEM subjects, and that brought me to consider enrolling in chemical engineering. The second place, let's say, contender was informatics, which is interesting if you think about the path that I take afterwards, which allow me in a way to bring back that passion that I didn't have a chance to explore there now in my research. And at this stage, it was very interesting to overcome the doubt about making such a big change from having studied humanities in high school and going to a STEM university. But I have to say that that was very interesting, challenging at the beginning, but I was, let's say, maybe because I knew that I was starting a little bit behind, I was even more motivated to make it. And so I really enjoyed my time as a chemical engineering student. So the next crossroad was during my research journey. I had at some point to choose whether I wanted to try to find a job that kept me closer to home, or if I wanted to explore different opportunities abroad to broaden my horizon, my network, and professional development possibilities. And I used to always say that, no, I didn't want to go abroad because I liked it where I was. But then after going abroad for the first time, I realized that it was possible to gain so much from these experiences and to grow. And I really embraced the opportunity to go abroad again when it presented itself. And all the learning that came with it, all the challenges that came with it, but all the rewards as well. So, and right now I have to say I'm very happy I made that decision. And there is also another should I stay or should I go question, which presented at multiple points during the journey, which was about staying in academia or going in industry. So the first time was right after graduation. Should I go for a PhD or should I apply for positions in industry? At the time, I had the fear that, I mean, the conversations, what you were hearing was that, yes, if you take a PhD, it might not be so valuable afterwards in a company. So sometimes you will not be rewarded for having an additional degree. So why spend the time? But on the other hand, I was very passionate about the topic that I was pursuing. So that was, in the end, the main driver that made me choose to go for a PhD. And afterwards, when I was toward the end of my postdoc, again, I was trying to figure out, so what's next? And Stavros summarized beautifully all the considerations and the pro and con matrices that I was writing as well and considering, and all the aspects. What really helped me at that point was talking to people and also taking part in a mentoring program. So a shout out to the Researchers Beyond Academia mentoring program by EFCE. I think they are still running it. So every year or every other year, they have a new cohort of mentors and mentees that discuss. They allow you to connect with an engineer or a professional working in industry that help you focus on your motivations and your priorities, and so that you can better orient yourself in thinking about next steps. And that really helped me to realize that for starters, the dichotomy industry-academia was a false one. And again, as Stavros said, there are more options out there in which you can find the things that you value for your working life. So I was applying for both industry and academic jobs, and the one I obtained was in the end an academic position, which is where I am now. But taking part in this program made me way more intentional about the opportunities that I was or I was not pursuing, because I had more clarity about which were my values and my priorities at the point, which was very, very helpful. But at the time, it was quite also interesting to think about pursuing a career in academia while the narrative around it seemed to be so negative, because as many have pointed out, you work long hours, you tend to have no unstable positions, there is compulsory mobility in a way, so that can be a negative for someone. And there is also a prevailing, let's say, anti-scientific feeling developing after the pandemics, which make you wonder, am I holding on to a sinking ship? There is even a subreddit called Leaving Academia, if you believe it or not, dedicated to exchanging tips about switching careers, but the tone over there is also sometimes quite negative, I have to say. And sometimes we joke about not being miserable PhD students, but at some point papers came out to support the fact that there are some challenges in the research working environment relating to mental health. And I remember that in my office when I was a PhD student, someone had printed out this paper and put it on the door of the office, which felt quite, I don't know, daunting in a way. And sometimes when you consider these things, which can be coming from systemic issues with the academic sector, you can feel a bit powerless and don't know what to do about it. What helped me? And one other thing is, I remember watching the movie Oppenheimer last year and being really struck by this exchange, which I think really encapsulates the pressure, the performance anxiety that sometimes can be so pervasive in the academic environment. So what can you do with it? I wanted to talk about a couple of initiatives that I've taken part with that help to try to change the culture around this in academia and maybe slowly push for change. So the first one is called Failing Inspiring Resilience, and this was an initiative by a group of PhD students and postdocs back then. It was founded in 2018. Now all these people have moved to either academic or industry positions around the world. And it was about trying to break the silence about failure and the pressures that people feel working in academia, by inviting people to share their experience in the format of like a TED Talk, if you like, And we have organized events in 3 continents, several cities, and recorded all of the talks, and you can find them on YouTube. These are 2 of my all-time favorites. And I found that by joining forces with others and creating community was really powerful to break the feeling of being alone in experiencing sometimes challenges during your PhD journey. So I tried also to continue this kind of engagement after moving on to postdoctoral and then permanent academic position, by taking part in a cost action called REMO, which launched a large-scale survey about the working conditions in academia in order to have data for policy recommendations about the reforming of the research environment. And I'm happy to say the survey, the data collection was quite successful, and the paper is now under review. So we will be able to hear about the outcomes of the study very soon. And overall, on the whole, we can also talk about a sort of an iceberg model concerning our CV. So on one hand, there are the things that you make on your CV and that you can talk about openly, and then there is all the things that you attempted that didn't go your way, and but still you put a lot of time and effort in it. And just so to give you an idea, this is how the numbers look if I look at my CV. So around 20% of successful applications, those could be grants, awards, positions applied for. Then there is a good 75% almost of unsuccessful applications, and some which, to use a sport metaphor, could be called like own goals, where I made mistakes, where meant that I sabotaged my own chances. And I think it's important to talk about this and to say this, because we're all human and we are allowed to make mistakes, and we shouldn't shy away from that. And it's also important to recognize the role of luck in this spread, because you will put your effort 100% of the time, not only 20% of the time, and that means that and everybody else around you will also do the same. So it shouldn't reflect on your motivation and on your self-worth if things don't go your way. It's very important to build a resilient mindset and not be discouraged by that. So just to sum up and conclude, the main things that I have learned along my journey so far is that you should not be afraid of changes. When I was a student and I was looking at how the academic job looked like, I thought, I don't think I will like that. It's very different from what I'm doing now, and maybe it doesn't suit me. Now that I am there, I have to say that sure, things changed, but I changed as well, and I find myself really enjoying my current job and roles and responsibilities. So it's difficult to anticipate the ways in which you and your surrounding will change, but so one should be open, at least to this to the possibilities, as also Alexandra was saying. And it's important to develop clarity about what are your drivers, your motivations, and your goals, because that will help orient you in a direction that will allow you to find you satisfaction. It's not about pursuing a singular goal, I think, rather than being true to yourself along the way. Because sometimes paths are always depicted as being divergent, but that's not always the case. Sometimes they're only detours that lead you in the same place, just more rich because of the experience that you gain along the path. And there will be struggles, and it's normal to struggle and to experience moments where you have doubts and that are more challenging than others. And I have to say, after getting my current position, so a permanent academic position, I experienced the strongest episode of imposter syndrome in a way that I had since my journey began. And I think that having engaged so much and openly with this kind of conversations really helped me to see through it and to face it with a very different, let's say, mindset. And finally, one mantra that served me well is to think that life is a marathon, not a sprint, and that in the end, you are only competing with yourself. So you should measure your successes along that way and not be concerned about what other people are doing. You are on your own way, on your own journey. Thank you so much for listening, and I'm happy now to join in the panel for questions.
There you go. Thank you so much, Eleonora, as well. It was really honest. I think your presentation and sincere, and I really like it. Thank you. Now I would like to welcome all the other speakers with the cameras, and I will share my screen again. So we have the panel started. Give me 1 second. Okay. I have prepared some questions for you. I think the questions that I prepared, or the team has prepared for you, are really in line with with what you have shared in your career path. So I think it will be very nice discussion. Good. So Maria, Stavros, and Alexandra, currently you work in, I would say, more in industry, and Eleonora, you work more in academia. If you have to make the transition, or you were deciding how to make the transition, you were doing pros and cons of what to choose. If you are advising someone that wants to do the transition, or whichever way, what skill do you think will make this transition easier or more successful, or what a kind of experience do you think it will enable them to make it a success on that? And I will do like this, and look, that's Maria Sofia's turn. So I like to hear all of you. What are your insights?
Yeah, okay, I'll take the question. So based on my experience, of course, I can say more about the transition from university, so from academia to industry. And it's very interesting. I really like this question because actually when I started my current job, or my previous role in my current job at Covestro, for me it was really the first experience in industry. So in Italy, unfortunately, we don't have, or at least I come from south of Italy. It's not a very industrialized area. So during my studies, I had not the chance to do any internship anywhere in a company, like I see here in Germany, for example, people like students do during their academic journey. And that's, I think it's already a great advantage if you can do an internship in a company, just to see how the things in a company works, because it's quite different than in academia world. And what I would definitely focus on as a academia a person who works in academia and would like to do this switch is definitely communication skills. So presenting ideas should be, let's say, it's one of the very most important skill that you need to have to communicate your ideas, but also to solve conflict. So not only communication skills in a way of speaking, but also in a way of listening. So being empathetic, and like also having emotional intelligence to understand what also the other is trying to say. And another thing that I would put value on is strategic thinking. So in the academia, or at least when I was doing my PhD, I was focused on my project and on my task, and I had ownership on the project. It was my project. In industry, it's not like that. You have many groups, you have many parties, you have to think who is benefit from that, why are we doing this, who is involved, which is the best strategy to implement this project or this task. Things that, for example, I didn't learn during my academic journey. And the third and most important probably is flexibility. It was already said in at least 2 or 3 talks. So the capability to adjust to changes or uncertainty is also very important to try to do this transition from the academic to industry, and also probably vice versa.
Thank you so much. I'll move to Stavros. Same question. What skills or competencies do you prioritize when making a transition from academia to industry or an industry to academia?
I think Maria Sofia covered most of the skills that someone should prioritize. What I would add is the time management in terms of having the ability to meet deadlines and also deliver what should be delivered. I mean, the deliverable report, what is the final target. So this is one of the skills that you don't develop or you try to develop in academia, but it's not fully developed, I would say. But it's very important to have it when you make the transition to the corporate environment.
Perfect. Thank you so much. Alexandra?
Yes, I highly agree with what both of you did say. I would say like the most important, so I did the direct transition from research and development to consulting, which I think in terms of rhythm and work is the closest to industry. And I would say you need to get comfortable with ambiguity and speed. That means like sometimes we'll have blank sides on your work and you don't know everything, you don't have all the elements, but you need to deliver. And that's something that you don't have space for that in research because everything needs to be proper and justified. And in the industry, sometimes you need to deliver and it's okay. You need to learn how to deal with stress and about that. And it's way more fast-paced, I would say, way more dynamic, and you need to be prepared for that and accept that sometimes it might be too fast, but you need to catch up with the rhythm, learn, and do things at the same time to deliver properly on time.
Thank you.
Thank you.
I just want to clarify that I will switch the order so you don't have to be always last. Eleonora, I don't know if you have anything else to add to the skills of the transition.
Well, when I was, I didn't eventually do a transition myself from academia to industry, but when I was actively looking into it and thinking about it and discussing with my mentor, one big realization was that a lot of the skills, you develop a lot of very useful transferable skills during your PhD, for example, and it's important to be able to communicate those and to recognize those and the value that they can have in a corporate environment, for example. The ability to multitask and to deal with different with the deadlines and commitments. Sometimes the times of research are definitely not as fast-paced. So this is something that looking at the other side might require somewhat patience and persistence in terms of skills that coming from an industry background to an academic project, one would need to show. And of course, passion for learning and being able to be independent and self-reliant. It's true that we collaborate in research quite a lot, but you need also to be able to take ownership of your project and be again, able to push it forward.
Thank you, everyone. I will move now to the next question that it was also a little bit discussed during Eleonora's presentation, failure. I include myself. It's quite easy to avoid making a big change due to fear of failure, fear of that it will not go as planned or that it will be the wrong step. When moving to a new location, a new country, switching from academia to industry, I mean, for me, the fear was always there, and I think it's always there. And it's okay. Like Eleonora said, it's okay to fail. And of course, most of the times probably will go okay. But I would like you to share what is the most valuable failure that you have faced and how do you navigate it, also to share with all early careers that are watching that it's okay and that people move on and it's not nothing that it will completely destroy your career, basically. And here, I think I saw, okay, first, Stavros.
Well, nice question, I have to admit. First of all, as I said also during the presentation, it's and also as you emphasize, it's absolutely normal that you will face failure during your career, during your life generally. Personally, the main obstacle in terms of failing that I faced was in the beginning. When I graduated as a chemical engineer, holding a master degree, I was looking for the next step. I was applying for different positions in across Europe. I have to admit that like 90% of them I failed, and then maybe 10% that replied. I went to the interview phase and then I failed again. For several reasons. I was not experienced, I wasn't qualified. But how this ended up to start thinking of a different step, which was a PhD. And then this brought me to Ghent, where I did my PhD. So eventually, you can say that it changed the career pathway. Maybe if I succeeded in the beginning during the applications, I would go directly for a job. But now I navigated through academia as well. Yeah. So this is normal, and indeed, then failure in smaller scale could be during when you are in a position, either PhD position as a PhD student or as an employee in a company. You will face failures, and this doesn't mean that you don't need to try. What I always say is that when you try, you have higher chances than when you don't do anything. So you try, you fail, still the chances are there.
I love it. Thank you. Maria, Sofia, any insights here?
Maybe. So honestly, if I look to my career, I was always on the right place at the right time. So I basically, from an external point of view, might seem that I didn't have any failure, because really after my master, I could smoothly join this PhD program. And already at the third year of the PhD program, I was basically hired from Covestro, and it seems like everything smooth. And of course, as Eleonora said before, there were always points in which I had to take decision, and I was unsure what to take. But more or less, I always quite challenge myself and always like be straight on my goals. And I think, I mean, this is also a bit of a failure. So I think that taking some breaks and thinking about what you really want to do, and staying true to yourself, and not jumping from one thing to the other, and trying not to really like having this FOMO of not doing something. I know that it's difficult because, yeah, I can say that in first person. But I think if you don't listen to yourself, you will face failure sooner or later. And for me, for example, I didn't focus enough on my health, and the last 2-3 years of, yeah, basically now it's getting better, but I suffered of a lot of back pains. And this is really, I think, a consequence of the fact that I didn't take any breaks, not for my mind, not for my body. And yeah, so I think it's important also to just take a breath and not being always want to be, let's say, perfect and fast, because in the end you have to give it back one day.
Yeah, I completely agree. Thank you so much for sharing. Eleonora.
Yeah,
Do you have
so
anything to share?
I thought maybe I can say something that all the PhD students in the audience, hopefully not, but maybe will experience someday, which is working very hard on a research paper and getting it rejected. This was a case for a piece of research that I did at the end of my PhD, and that I thought was the most original contribution I had, and I was very, very proud of. And I was trying to, I wrote it up, and we submitted the paper, and it got back with very, very negative comments, which was, oh, wow, okay. And then we try to take those into consideration to make modifications and revisions to the work, as you do during the peer review process, and we sent it back. And it came back with even worse, let's say, reviews and comments. And so that can be very, very discouraging, especially when your perception of that is so different, right? So it's very important in those cases, I think, not to take things personally and detach, let's say, yourself from your work. One thing that sometimes people in academia tend to do is tie up their identity so much to their academic self, let's say, but you are more than your work, and if something in your work doesn't go well, it doesn't mean that you are a bad person, let's say. So what do you do in that case? We try to look for a different avenue for publication for the work, taking into account what we felt were good feedback that we got from that review process, and we managed to publish it in an even better journal than the one we had initially considered. So you can say eventually that was a success, but definitely was a struggle to get there, and a learning opportunity also.
Very insightful. Thank you. I think I lost track. Okay, good. Alexandra, do you have any failure to share?
So luckily, I can say almost the same as Maria Sofia. Until now, so I'm very early in my career, so I didn't get many opportunities to get no's, to be honest. But I would say it's not a failure. I would rather say a change of plans. When I went to Hong Kong, I had applied to classes that were purely chemical engineering related to biotech also. And what happened is none of them opened, and I was already there. And what happens in this case is they can send you back home, but I found a way to change my whole plan and take business classes. And actually, I think the best thing in this case is to embrace the change and make the most of what you're learning and what you're getting. It's not really a failure. I would call that a change of plans, and just don't let this stress you out or get in your plans, because there's always something to get from any situation, any learning, anything.
Thank you. Yes, I really like the concept of it's a change of plan. And it's actually what it's going to be. It was not your path on the first way, maybe, and then this is what you built. Thank you very much, everyone, for sharing honestly. A little bit behind time, so I will do one more question, not all of them. Give me 1 second. I'll do this one. I like it more. To closure. So I think all of you have had also all of you had international experience, have switched from different universities, have had different experiences in internships, academia, industry. Is there something that you think, oh, I wish I have done this, or I have the opportunity or the time to do, or something that is still in your to-do list in the next 5 years that you would like to share and inspire others to do, maybe think about doing it? Oh, sorry. Yeah, Maria Sofia.
Well, like I said before, it's during my talk. It's not long that I started like to work more with people, and probably also because of the Corona times that we stayed at home so much, and now home office became basically the rules or almost the rule in many workplaces. I'm really enjoying to work with people and not only with data and models. So I hope I can continue doing that. And yeah, who knows, maybe one day I would like to be the leader of one small team. That will be also nice, but we will see.
Fantastic. Eleonora?
I don't think I have anything really big to say about this. Thinking back, I wish I went abroad during my master's, so I took the opportunity to do an Erasmus, which I didn't, because otherwise I could not finish on time and would not be able to start the PhD on time. So, but not really the chance to do it anymore yet. So.
Yeah. Stavros.
Yeah, I was trying to unmute my microphone. Yeah, Eleonora just captured what I wanted, what I had in mind. One of the two steps that I wanted to do, and not that I didn't have the chance, but I didn't do actually. It was to go abroad during my master's, doing Erasmus. But the second one is also going to US. Maybe if I look back, I would take this step like a few years ago when there was opportunity to do it, but for personal reasons or for being also a bit scared to cross the Atlantic, I didn't do it. Yeah, I don't know if I regret not doing it, but maybe now I would try.
Okay, then next year you can come and share us all about your experience. I can give you more than 1 year, but you can come back and share your US experience next time. And I think Alexandra.
Yes, so to answer the question, I'm not sure about what I would have done different because, as you mentioned earlier, one of you, I kind of have some FOMO also, so I feel like I did a lot because I feel FOMO, so I went abroad many times. I experienced research, development, consulting. Now I'm building my startup, so I don't feel like I didn't have the chance to do something, but something that I really want to, and I will try to make the chance to have it, is I would like to have my own successful startup, which I'm working on. And I think like chance, like it's not about not having the chance, it's about time and dedication, and then you build your own opportunities. So if you really want something and you work towards it, you're gonna get it eventually.
Thank you so much for sharing as well. For me, it was also doing an Erasmus. I didn't know that this existed when I was doing my master's, and when I moved here for my PhD to Europe, I learned about it. And I was in the middle of the PhD. Of course, I couldn't say that I'm going back now to do Erasmus simultaneously. And then I started working in industry. And as you said, Eleonora, is I mean, doable it is, but it will be really a step back. But I love so if anyone, bachelor student or master student is listening, look into the Erasmus because the programs are amazing. You do like 1 semester in each country and different universities, and I think it's an amazing experience for what I have heard. I never done it. Okay.
Yes,
And
I would
with
say
that,
definitely go on Erasmus. Don't miss out on Erasmus. And if you're interested in going further, Asia or Middle East or anything, you can reach out to me. I can help with that. Don't be afraid. It's just the best experience you can get, to be honest, when you're in uni.
thank you so much. Any last comment that anyone wants to share? The floor is open. Maria is going to answer the question. No, she already answered the question that was in the chat in written form. And with that, I want to thank all the speakers. It was extremely nice to have you here and hear about your different and really diverse career path. It was really nice for me also to, I mean, of course, I read your CVs before, but to hear the experience and to hear how was it. And I'm sure it was very beneficial for all the listeners and the future listeners on YouTube. And I have put in the chat all the LinkedIn's links of the 4 speakers, so connect with them, and they all offer help if you have any questions or don't know how to move forward. And you can join the early career section and be part of this network of early careers. And if you don't have any other comment, I think we can close today. And thank you everyone for joining. I hope it was helpful.
Thank you very much.
Thank you very much, Sofia.
Thanks a lot, Sofia.